Hi students, good evening to everyone. Myself Mahesh, chemistry faculty from Venper Academy. So I hope everyone very well done in the examination. We'll go for the question paper discussion. Question number 1, students. The volume strength of 1 molar of H2O2. So volume strength of 1 molar of H2O2 is direct question only this one. Since we know very well 2 moles of H2O2 will generate the 2 moles of water and as well as 1 mole of oxygen. That means 2 moles of H2O2 can give 1 mole of O2, right? 1 mole of O2 means 22.4 liters will be generated. Then with respect to 1 mole of H2O2 can generate half of this. That means 1 by 2 mole. 1 by 2 mole. So 1 by 2 mole means 11.2 liters. So nothing but 1 mole of H2O2 present in 1 liter. This is molarity, right? This is molarity that can produce the 11.2 liters of oxygen. So answer should be the C is the correct one. So next question number 2, student. The amount of sugar required to prepare 2 liters of its 0.1 molarity of aqueous solution. So he is asking here, volume is given, V is 2 liters. And molarity is how much they have given, 0.1 molarity. And they're asking amount, W2 is how much. Then MW2 for sugar, we know how much, 342 grams per mole. Okay, so amount, so molarity formula we know, molarity equal to W2 by MW2 into 1000 by V in ml. So they have given liters, right, the value. So convert into ml, multiplied with 1000. So we'll get as a 2000 ml is there. So substitute in this equation. So molarity is 0.1 mole and W2 we have to find how much weight is required, and MWT is 342 into 1000 by 2000. So on simplification of this one, we'll get answer should be the base students. WT equal to 68.4 you will get. Okay, next question number 3. Which of the following is energy is possible for excited state of hydrogen? Hydrogen energy they are asking students. Direct question this one. So the positive value is not possible here. Positive value is not possible. So among these two, we have to check here. So energy En equal to minus 13.6 into n square by z square. Sorry, z square by n square electron volt. Z square by n square. So Z is for hydrogen should be the 1. So he is telling is a possible electricity state. So if n equal to 1 I have taken, then both will be the 1 square by 1 square. We are getting is minus 13.6 is the first energy level. So option is not there, minus, but here positive is there. Suppose another one, if suppose n equal to 2 I have taken. So minus 13.6 into Z is 1 square divided by n square is nothing but 2 square. So on simplification, we'll get answer should be here minus 3.4 electron volt will get students. So check the option C is there. That is the possibility is there. So minus 6.8 is not possible. So option C is the correct one. So next we can go for question number 4. Assuming 2s2p is not operative. Very good question, students. 2s2p is not operative. Which of the following is paramagnetic substances? So 2s2p is not operative means we have to take here symmetrical diagram according to MOT. So intermixing of orbitals are not there. So we have to take as a symmetrical diagram for p substitute. So symmetrical diagram means we'll get here 2 orbitals. Here should be the 1 and here should be 2. Like this will become. So here how many electrons we have here? Suppose we can take as a C2. C2 is 12 electron system, right? So up to 1s energy level, 2s energy level, 8 electrons is over. Then 2p energy level, how many electrons we have here? In 2p we can check here 2p2 and here should be the 2p2. Fill the electrons here. Total 4 electrons we have here. So fill the electrons in the lower energy level. Here 1 electron, here 2 and 3 and as well as 4. So we can check in the valence cell. So which is the having the unpaired of electrons are there now. So this is paramagnetic nature, students. Option A is the correct one. If you go for B2, you will get as a diamagnetic, N2 also diamagnetic, Bu2 will be doesn't exist. So answer A is the correct one. Usually this is not possible. This is not possible, but just they're telling as a not operative, just assuming that. If you assume means intermixing orbitals are not there. So that's why you have to go for symmetrical electronic configuration. We have to go for this. So answer should be A is the correct. Go for the question number 6. Question number 6, the van der Waals constant A for O2, N2, NH3, CH4, and which gases can mostly liquefy. So mostly liquefied means A value is directly proportional to the liquefaction, we can tell. Directly proportional to the liquefaction. So A value is which is greater here 6.36, 1.39, and 4.17 and 2.25. So 4.17 is the highest value. So that is responsible for NH3, right? So option C is the correct one. Option C is the correct one. Next question number 7, students. Which of the following does not undergo HVZ reaction? Right question now. HVZ reaction, when it will undergoes, when alpha hydrogens containing carboxylic acid, that means HVZ reaction is possible. So check here, propanoic acid is there. So propanoic acid means this is the formula. So we have here alpha carbon is 1, 2 alpha hydrogens we have here. 2 alpha hydrogen in option 1. So option 2 we can go for ethanoic acid, CH3 COOH. So this is the alpha carbon. 3 alpha hydrogens we have here. Fourth one we can go here 2 methyl propanoic acid. Third one 2 methyl propanoic acid. 2 methyl propanoic acid. This is the 2 methyl propanoic acid. This is the alpha carbon. So 1 alpha hydrogen we have here. So fourth one 2, 2 dimethyl propanoic acid. 2, 2 means this is the structure. Here alpha carbon we have, but alpha carbon doesn't having any hydrogens, right? This will be doesn't having any hydrogen. So 0 alpha hydrogens. So does not undergo means it must be does not having any alpha hydrogens, carboxylic acid. So answer should be the 4 is the correct. Option D is the correct one. Next question number 8. In which of the following equilibria Kp does not equal to Kc? When does not equal? If del Ng does not equal to 0, does not equal to 0, then Kp does not equal to Kc. Let's check here. These are the in equilibrium is there, and here this is N value is del Ng equal to 2 minus 1. So solid we are taken as a unity, right? Solid we can take as a unity. So 2 minus 1 we are getting as a plus 1 we are getting. So del Ng does not equal to 0. Then answer should be A is the correct, students. If you go for here, option B 2 minus 2 we are getting 0. Option C also we are getting 2 minus 2 0. Option D also we are getting 2 minus 2 we are getting 0. All the cases will be 0. So only option 1 cases does not equal to 0. So then Kp does not equal to Kc. Question number 9. The heat of combustion of carbon and carbon monoxide minus 395, they have 393.5 and minus 283.5 kilojoules they have given. Then heat of formation of carbon monoxide they are asking here. Heat of formation. So we'll go for here. Carbon react with half mole of O2 will gives carbon dioxide, right? Will gives carbon dioxide. So this is exothermic reaction, right? Del H equal to always exothermic reaction combustion. Then formation of CO they're asking. So del H combustion, for that they're asking here combustion. So del H equal to summation of enthalpies of reactants minus summation of enthalpies of products we have to be considered. So what are the reactants we have here? In this case, reactant is carbon. Oxygen is elemental form, can take it as 0. So carbon is they have given here minus 395.5 minus 393.5 minus of minus and 283 products is CO. Product is carbon monoxide is formation is 283.5. So students, if you be simplification means we'll get answer should be the minus 110 will get, not 5 also, 110. So option C is the correct one. Next question number 10. The freezing point of the solution containing 0.1 gram, 0.1 gram they have given. So W2 is they have given as a 0.1 gram, and MW2 they have given MW2 for this 319, 329, and weight 100 grams of water they have given, 100 grams of water means that is W1 is 100 grams. So weight of solvent. Then Kf they have given constant 1.86. Then freezing point of the solution they are asking here. Freezing point of the solution. Since we know we have to apply here I factor also. Band half factor we have to apply. So del Tf equal to I Kf into M, right? So what they're asking here, freezing point of the solution. So del Tf means what? Tf T naught F minus Tf equal to I into Kf into W2 by M, W2 into 1000 by W1 in grams, right? In grams. This is the formula. So they're asking here Tf solution, they're asking solution. So since we know very well T naught F for water is how much? T naught F for water nothing but boiling point of water is how much? 0. 0 minus Tf equal to I factor for this compound is how many ions it can produce. This can produce the 4 ions can produce. So I factor should be the 4 and Kf they have given 1.86 and W2 how much they have given 0.1 and divided by MWT is 329 and 1000 divided by W1 they have given as a 100. So since students you do simplification this one will get as a Tf here. Tf equal to will get minus 2.3 into 10 to the power of minus 2 will get answer there. Minus 2.3 into 10 to the power of minus 2 will get answer. Okay, so option should be the A. Option should be the A. So next question number 11 student. They have given us here reduction potential values. They have given reduction potential values on oxidation power. The species will be increased oxidation power. So reduction potential value SRP value is negative. It's a reducing agent we can consider. Okay, SRP value is positive. It's a strong oxidizing agent we can consider. So let's see his oxidizing power which is having more positive value here 1.81, 1.67, 1.61 and as well as 0.20. Let's check here which is the highest value students. Cobalt is the highest value. So this is the first one, number 1 I'm giving here. And check here later will be 1.67, 1.61, 1.67 is 2 and here 1.613 and as well as this is 4. So serial you have given. So option you can check means B is the correct students, cobalt, lead, cerium, bismuth. So that is the increasing order we can tell. So next go for here 12th number, question number 12. This is somewhat tricky student. Question number 12 you have to be see. What they have given here, 2 reactions are there, that is R1 and R2, identical free exponential factor. A is constant. A is same for both the thing, reaction 1 and reaction 2. So activation energy of R1 that exceeds to R2 by 10 kilojoules, nothing but for R1 activation energy is EA1. Okay, for R2 for activation energy is EA2. So what is telling means R1 is exceeds R2 by 10 kilojoules. That means here you can take here EA2 equal to EA1 plus 10 kilojoules we can take here 10 kilojoules. Okay, if K1 K2 are rate constant then R1 and R2 respectively 300 kelvins. They're asking here plan K2 by K1. Since we know very well here Arrhenius equation K equal to AE power minus EA by RT. So this is the formula I have applied here. So this is K1 I'm taking here. This is EA1. Okay. Then next I'm taking the formula K2 equal to AE power minus EA2 by RT. EA2 by RT. Since we know very well here A is pre-exponential constant is they have tell us a identical. Then what we have to take here K2 by K1 I am taking here. So K2 by K1 that equal to E power minus EA1. So this will be plus will come here minus EA2 divided by RT will hit RT. on simplification is. So I'm doing logarithm both sides. So K2 by K1 equal to logarithm you do means e power will be goes. So EA by E1 by EA2 EA1. So if you substitute here EA2 value, we'll get as a 10 kilojoules. 10 kilojoules means convert into joules, 10 into 1000 joules divided by R value we know very well here 8.314 joules into kelvins 300 temperature. So on simplification students you will get this one answer should be the option D. Okay, so next question number 13. If uranium mass is 238, uranium mass is 238 and atomic number is 92. Atomic number 92. So emits alpha particle. The products are mass number and atomic number. Since we know here alpha particle is emitting, alpha particle is emitting, and what are the products they are asking? Alpha particle is emitting means, so alpha particle is nothing but helium particle only. Helium mass is 4 and as well as atomic number 2. So we have to be subtract here 92 minus 2 will get as a here 90. So 90 is the atomic number we'll get. And another one is what you're getting here 238. We have to subtract here minus 4. So we'll get here 230. Sorry. 234 will get. So 234 and as well as 90. 234 and as well as 90. Option B is the correct. Alpha particle we have to remove. Very easiest question. Next question number 14. And what is the reason for temporary hardness of water? We know very well temporary of hardness is what is the responsible. Calcium and as well as magnesium bicarbonates are responsible for the temporary hardness. Permanent chlorides and as well as sulfates of calcium and magnesium we can take for permanent. So they're asking hardness for temporary. So option D is the correct one. So question number 15. In which of the following reactions H2O2 can act as a reducing agent? It's acting as a reducing means undergoing reduction, right? Oxidation, right? Suppose H2O2 undergoing here in the form of H2O. Suppose H2O it is undergoing. So what is the oxidation state here? -1 and here should be the -2. So this place to this place we can observe here it is undergoing reduction. So this we can call as a oxidizing agent. So this is not correct one. So another an example if you take here H2O2 convert into O2 form. So this is -1 state, this is 0 state. So -1 to 0 it is oxidation. So oxidation means it is acting as a reducing agent. Let's check in the which case H2O2 is converted to O2 form. Option A is not. Option B is converting, right? Option C also not. Option D is converting. So 2 and as well as 4. 2 and as well as 4 will become students. Now 16. The electronegativity of aluminum is similar to, since we know very well here lithium, beryllium. Under that what elements are there? Lithium, sodium and beryllium and magnesium, and here boron, aluminium. Boron, aluminium. So they're asking here electronegativity of aluminum is similar. Diagonal relationship we have to check students. Diagonal relationship we have studied in the periodic classification. So aluminum and as well as beryllium having the equal electronegativity. What is the reason means? Due to diagonal relationship. So option C is the correct one. Due to the diagonal relationship. So 17th question number 17th. The compound that does not produce the nitrogen gas on thermal decomposition. Since we know very well azides will give nitrogen and dichromate also will give unheating nitrogen and ammonium nitrate also will give nitrogen, but ammonium sulfate doesn't give. So option D is the correct one. Next question number 18. The percentage of p character in orbitals forming pp bonds in P4. Since we know very well P4 is tetrahedrally bonded, right? P4 is tetrahedrally bonded. The red phosphorus is, since we know in polymeric structure, red phosphorus is in polymeric structure. So this tetrahedrally bonded means it is sp3 hybridized. sp3 hybridization means p character, right? They're asking here. So S is 25%, Then remaining P is 75% pressure. So option should be D. Option should be the D one. So next question number 19. Question number 90, students, we have to be analyzed here in inorganic chemistry here. The thermal decomposition of manganese compound on 513 Kelvin. So this is the manganese compound. They have heated here 513 Kelvins. Results Y compound here. And MnO2 on gaseous compound. In the product, Y compound as well as MnO2 is produced and the gaseous product. And O2 also will be gaseous product is released. So MnO2 on reaction with NaCl concentrated and as well as H2SO4. So this MnO2, what is the generated here? MnO2 we have rotated with NaCl and concentrated H2SO4. It will use pungent smell gas, Z, pungent smell gas. So what is the X, Y, Z they're asking here? The X is nothing but manganese compound. X here. So you have to find here X and Y and as well as Z we have to find. Since we know very well when will the manganese dioxide and as well as oxygen is released, when KMnO4, potassium permanganate, 2 moles of potassium permanganate on heating, it will use K2MnO4. Permanganate is converted to manganate and as well as MnO2 plus oxygen will be released. This is the first equation. So since we got here X is this, X compound is this, then Y compound they have, we can go here. Then MnO2 they are treating with NaCl. NaCl. So how many moles of NaCl we have to take means 4 moles of NaCl in the acidic media. So if you treat means here it will produce the MnCl2 plus Cl2 gas will be generated. This is the pungent smell. Cl2 gas will be generated. This is the pungent smell. This is the compound is here compound Y, this compound Z is this. Pungent smell. Chlorine gas is pungent smell is present. So one is potassium permanganate, another one is the potassium manganate, another one is the chlorine gas. Option C, check students, answer C the correct. So in this chapter, they have included D black question and as well as they have included chlorine preparation method. T black also they have included. Next question number 20. The transition element having the least enthalpy of automation. Least enthalpy of automation, we know very well left to right number of in 3D series. They have given all the 3D series left to right. What will happen? Number of unpaired electrons are decreases. So least one is we can take as a copper we can take. So usually zinc is least one we can take. Zinc is least. But if you take as a here is telling as a transition metal, right? Transition metal means zinc is not transition metal. So we have to check vanadium, iron, copper. So vanadium is the highest ionization enthalpy. The least one is copper we can take. Why? Because it has only one unpaired electron source in the valence cell. So this is the least one. So option D is the correct. So vanadium is the highest one we can tell among the 3D series itself. If suppose they have asked the in 3D series means zinc will come answer, but he mentioned as a transition element. So zinc is not a transition element. So answer is getting as a D is the correct one. So question number 21, the coordination number of cobalt, aluminum in this complex and as well as this complex, they are respectively they're asking there. So coordination number is determined its density, right? Around the how many coordinate covalent bonds are present. So chlorine can form 1 bond and ethylene diamine 2 there, and each can form 2 covalent dative bonds. Totally, so we'll get as a 5 coordination number is 5. And here aluminum is there, C2O4 is a bidental ligand. So how many is there ligands? 2 and density is 2. So we're getting is 6 is the its coordination number. So 5 and 6 is the answer. 5 and 6 is the answer. Option D is the correct student. Next question number 22. The crystal field stabilizing energy. The crystal field stabilizing energy of the complex. They have given here what are the complexes are there. One is iron H2O taken 6 times Cl2 and K2 NiCN6. It's a octahedral complex, right? So splitting energy we know very well here. So here should be the T2Z and here should be the EZ. So T2Z value is how much we know? T2Z should be 0. minus 0.4 del naught and EZ value is how much here? Plus 0.6 del naught EZ value. So since we can apply here, that is for the octahedral complex. For tetrahedral complex, splitting is taking place like this. So Eg will be the lower energy and T2G should be the higher energy. So Eg value is minus 0.6. Why? Because lower energy, minus 0.6 del T, and T2G will be the minus 0.4 del T. Del T. This is the thing. So we can apply the how many electrons are there. We can do here. So iron is there here. What is the oxidation state here for iron? +2 state is there. Iron +2 state means 3d6-4s0. 3d6-4s0. Since we know H2O is weak field ligand. It's a weak field ligand. So weak field ligand means electrons will be doesn't pair. Since we know very well here orbitals, how many orbitals will be present in T2G? 3, and Eg will be the 2 will be present. Now fill the electrons here. So how many electrons? 6 electrons. 1, 2, 3, 4, 5. Then later will be pairing is taking place. 4 is there. Okay. So now calculate here. Formula we know very well. CFSC for octahedral complexes. T2G in number of electrons. T2G is how much? Minus 0.4 into number of electrons is how much here? 4. Del naught. Plus, and Eg, how many electrons we have here? Eg value is 0.6 del naught plus 2 electrons we have here. So since on simplification we're getting is a minus 1.6 del naught, and here plus 0.2 if you do means here 1.2 del naught will get. So 0.4 minus 0.4 del naught we got answer here. So this is the method to calculate the CFSC for octahedral complexes. So next go for tetrahedral complex. They have given here. In this case, nickel is +2 state, right? Nickel is +2 state, and chlorine is weak field ligand. Chlorine is weak field ligand. So electronic configuration will get here 3d8-4h0. 3d8-4h0. Nothing but here 3d8, 8 electrons we have here. So Eg we have here 2 orbitals. T2G we have here 3 orbitals. So first fill the electrons here serially. 1 here, 2 and 3 and 4, 5, 6, 7 and 8 I have filled. So now for the CFSC for this, what is the value for CFSC? CFSC if you calculated means Eg how much is there? Minus 0.6 into 4 del T plus minus, sorry, here it will be the positive, right? 0.4 plus 0.4 into 4 electrons we have here, del T. So on simplification, how much you getting, students, here? On simplification, you will get as a minus 1.2 del T will get. So option you can check here, students, which place is there? Sorry, not minus 1.2, it is 0.8 will get, minus 0.8. Sorry, minus 0.8 will get. So option B is the correct one, students. Simplify this, you will get easily. Okay. Next question number 23. Homo effect octahedral complexes. Metal ion M+3, 3 monodiethyl ligand L1 and L2L3. Observe here L1 is green color, L1 is green color ligand, and L2 is the blue color, and L3 is the red color one. L3 is the red color one. The increasing order of ligand strength they're asking. Since we know very well here ligand strength is directly proportional to the energy, right? Directly proportional to the energy. So we'll give here energy is inversely proportional to the wavelength. Energy is inversely proportional to the wavelength. Since we know very well VibGR, right? VibGR, VIBGYO VibGR. So VibGR range lambda values we know very well. Lambda values from VibGR violet to red color is lambda value is increase. Lambda value is increase. Then red to violet is energy values are increase. Lambda is, this is lambda increase. Here energy increase. Energy increase. This left to right. So which is having the more energy, students, here? Check here, they have given green and blue. So blue is the highest one. So L2 is greater energy, and later will be green L1. Then red is the least energy, right? Red is the least energy. So L2, L1, L3 we have to be considered like this way. So L2, L1, L3, which case is there? Answer C is the correct, student. Next question number 24. Wilkinson catalyst. That question. Triphenylphosphine, triphenylphosphine rhodium is the right question. So option C is the right one. Wilkinson catalyst. So question number 25, students. The following complexes they have given here, which is the diamagnetic complexes. Since we know very well, very easy to calculate this. So we know well here, iron is what oxidation state is there, complex K. Iron is +3 state. +3 state means D5 electronic configuration will come. So one unpaired of electron is present. Why? Because cyanide is strong field. So one unpaired of electron is present. So it is paramagnetic. Complex K is paramagnetic here. So complex L we can take here. So cobalt +3 state is there in the complex. Cobalt +3 state means D6 electronic configuration, NH3 strong field ligand. So 0 unpaired of electrons we have to take here. 0 unpaired of electrons means diamagnetic. So we'll go for here complex M. Complex M is also will be +3 state, cobalt +3 state, and strong field D6. It should be the 0 unpaired of electrons, and we'll get as a diamagnetic complex. Diamagnetic complex. And complex N we can go here, students. Oxidation state nickel is +2 state, and +2 state means D8 electron configuration will get here. It's a weak field ligand, so we'll getting is a 2 unpaired of electrons. You should be the paramagnetic. So again they have given complex O. Complex O, it is platinum is there. Platinum is +2 state. So +2 state is completely filled here. So D8 will come here. Then we can go here. It's completely filled. So 0 unpaired of electrons. Why? Because cyanide is strong field. So diamagnetic complex we can take. So zinc, nothing but compound P is zinc is +2 state. Zinc +2 state, it is D10 electronic configuration. We'll get 0 unpaired of electrons. You should be the diamagnetic. So the complexes they are asking as a diamagnetic complexes are which are. So look at here, diamagnetic complexes. L complex is diamagnetic, and M complex is diamagnetic, and O complex is diamagnetic, and P complex is the diamagnetic. LMOP. LMOP, option C. Check the student. Option C is the correct one. Option C is the correct one. Next question number 26. The compound used in treatment of lead poisoning. Lead poisoning. So which is used to remove the lead poisoning, EDTA we are using. EDTA we are using. Methylene diamine tetraacetate. It's a hexadental ligand we are using, students. That question. Applications of coordination chemistry, that place it will come. So question number 27. The Mond process is used for, that question, purification of nickel. Mond process is used for purification of nickel only. So next, question number 28. Oxidation states of metal in minerals, hematite and magnetite. Oxidation state they're asking here. Hematite oxidation state complex is Fe2O3 is hematite. Magnetite is Fe3O4. Since we know very well in this what is the oxidation state, +3 state will come here. In this we are getting as a average oxidation state will get as a 8/3 will get average oxidation state, but here given as a splitter. So both irons also in hematite, both irons also will be +2 state, but here difference are there. So what are those means? 2 iron atoms are +3 state will be present. 1 iron atom is the +2 state will be present. +2 state. Okay, so that's why 2 into +3 6 and +2 total 8/3 we are getting. So check here option D. In hematite +3 oxidation state, in magnetite +2 +3 oxidation states are there. Option D is the correct. Next question number 29. Absolute configuration. Very easy question. Directly they have asked me here, but you will be get confused little bit. So no need to get confused. We'll check here how to explain this. How to do this, I'll explain. Listen. So first we have to give the numbering according to the IUPAC nomenclature. This is 1, and this is second compound. This is the third compound. This is second carbon, and this is the third carbon. This is the fourth carbon. So second and as well as third carbons are chiral centers. We have to check the RS nomenclature for that. So give the numbering here. Highest priority have to give for higher atomic number. So oxygen is the highest priority, and here carbon and as well as here also carbon is there. So this carbon is connected with oxygen, but this carbon is connected with chlorine. So chlorine is highest priority, right, when compared to oxygen. So down I'm giving 2, and this is third priority, and fourth priority I'm giving here. So if you rotate means clockwise direction we're getting. So clockwise direction means R, but R becomes S here. Why? Because hydrogen is there, nothing but fourth priority is there in horizontal, configuration becomes reverse. So you are getting as a 2S, you are getting 2S, you are getting. At the same case, we can go here. For this also, we are directly connected with chlorine here. Here carbon, here carbon. This carbon connected with oxygen, this carbon connected with hydrogen. So number 2 here, and number 3 and number 4. So 1, 2, 3 anti-clockwise direction. Anti-clockwise means S become R here. Why? Because fourth priority horizontal. S become R. So 3R. 2S, 3R is the answer. 2S, 3R. So option A is the correct one. Option A is the correct one. So question number 30. Right question, students. This one is acidic order. They are asking here carboxylic acid, phenolic, and as well as substituted carboxylic acid and as well as phenolic groups are there. Since we know very well carboxylic acid is the highest acidic nature. Here donating group is there plus N, decrease the acidic nature. So third compound is the highest, then fourth one. Then phenolic, we know very well, phenolic here should be the withdrawing group is there, -I group. So that's why phenolic group is the greater, withdrawing group is greater here. So second one and last one is phenol. So this is the order where it is there. Option A is the correction. Next question number 31. When benzene sulfonic acid, para-nitrophenol is treated with sodium bicarbonate, it will release what type of gases respectively? Benzene sulfonic acid, since we know benzene sulfuric acid is very strong acid, if you treat with sodium bicarbonate, it will be released salt SO3 minus Na plus H2O plus CO2 gas will be released. The CO2 gas from the bicarbonate. At the same case, para-nitrophenol also. If you treat here means the same compound will get salt plus O minus Na plus and NO2, and it will release H2O plus CO2 gas. So both the cases, what gas is releasing? CO2 gas only. So option D is the correct one. The next question number 32. The number of unpaired electrons in nickel tetracarbonate. It's a strong field ligand, right? So 3D8, 4H0 with 4H2 will come. So total it will be jumps here. So you're getting as a 3D10 due to the strong field. So 3D means 0 unpaired electrons. That question is one NCERT. So 0 unpaired electrons. Next question number 33. The number of stereoisomers obtained on bromination of trans-2-butane. This is the trans-2-butane, students. And bromination we are doing here. Since we know very well here, bromination is anti-addition, and this also will be trans. So trans plus anti-addition will get as a meso compound will get as a meso compound, CH3, H and H will get as a meso compound will get. So trans plus anti-addition, both are anti. So trans also opposite, anti-addition also opposite. So we're getting the meso compound. So only one stereoisomer is possible here. Only one isomer is possible. So question number 34. The heating of 2-chloro-1-phenyl butane with 2-chloro-1-phenyl butane. Two-chloro-1-phenyl butane. This is the thing, right, students? 2-chloro-1-phenyl butane treated with ethyl sodium ethoxide in presence of ethanol. So nothing but elimination in presence of alcoholic elimination. Alcoholic elimination, beta elimination is taking place here. So since we have here, this is alpha carbon, this is beta, and as well as this also will be beta. So which side will be elimination taking place? So phenyl attached group side will be elimination is taking place, the major product. So the reason is what means we are getting is extra conjugation here. PH, CH, double bond CH, CH2 and as well as CH3. This is the one compound. So another one is if you eliminate here means PH, CH2 and CH, double bond CH and CH3. So we are removing the hydrogen here and as well as chlorine here. Then we are getting is this is the product. Suppose if you are eliminating the hydrogen from this place and as well as this place, so we are getting this product. So here extra conjugation is there. Why? Because it is attached to the phenyl ring. So this is major one we can tell. This is major. So this is X compound. This X compound on reaction with mercury acetate and followed by NaBH4. So this is, since we know very well what is the famous name reaction, oxymercuration and as well as demercuration. Oxymercuration and as well as demercuration, it will follows Marconic of addition. Follows Marconic of addition rule. Yes or no? NaBH4. So Marconic of addition, according to Marconic of addition, more stable carbocation benzylic quotient, so OH here and CH2 and ethyl group will come. So where it is there exactly, answer should be C is the correct. So first one is the elimination. You have to know alpha and beta, both the products you will get. Among that, this is the major one. Why? Because extra conjugation. So this is follows Marconic conversion. Marconic conversion, benzylic carbocation is the more stable. So that's why I have taken it here. I have taken it, this place is the major product I have taken. Answer should be this. Question number 35. In SN2 reactions, SN2 reactions, the reactivity order they are asking, SN2 reaction reactivity is which is less bulky group, that is more reactive. Depends upon the bulky nature. So methyl group is there and ethyl group is there and isopropyl and tetrabutyl, which is methyl is more reactive, right? So option B is the correct. Methyl, ethyl and isopropyl and as well as tetrabutyl. Okay, this is the based on the bulky nature, SN1 will be follows. Less bulky, more reactive towards SN2. So next 36. The synthesis of alkyl fluorides is best accomplished by diet question students Schwarz reaction. Diet NCERT question. So Finkelstein reaction is for iodine, iodoalkanes, for iodoalkanes. Sandmeyer reaction is aromatic. Okay, free radical fluorination is fluorine, that is unstable. Free radical fluorination is highly exothermic reaction, so it is impossible to prepare by free radical substitution reaction. So that's why one of the best method is Schwarz reaction. So next question number 37. A crystal is formed by two elements X and Y. X atoms are the corners. X atoms are the corners. So we know very well here, corners means how many corners will be present? 8 corners are present per cube into how much part is belong? 1/8 part will be belong. So on simplification, we'll get as a 1 only will present. X is 1. Then Y are at the face center. Y are at the face center. How many faces we have for the cube? 6 faces we have here. 6 faces into how much part is belongs? 1/2 part will be belongs. So on simplification, we'll getting is 3 is the answer. So X is 3, X is 1, Y is 3. So XY3 is the formula. XY3. Next, 38. The compound which reacts fastest with Lucas reagent. Lucas reagent means tertiary alcohols are more reactive than secondary and as well as primary. So butanol is the primary. So sorry, this is secondary alcohol. Butane, 1-ol is the primary. 2-methyl, 1-propanol is should be the primary. 2-methyl propane 2-ol, it's a tertiary, right? 2-methyl, 2-propanol. So nothing but tertiary butyl alcohol. They have given. This is the one. So 2-methyl, 2-propanol is this one. So this is the tertiary one. So this is more reactive. So option D is the correct. So question number 39, student. An organic compound neither reacts with neutral ferric chloride nor with failing solution. Nothing but it's not phenolic group, right? It doesn't have phenolic group, and failing solution means it doesn't has aldehyde group. Doesn't has aldehyde group. Doesn't use the positive test they are telling. So it doesn't have containing the compound doesn't containing phenolic group and as well as aldehyde group, and reacts with Grignard reagent and gives positive iodoform test. That means it should be the ketone, right? And it must be containing keto group, and it gives the positive iodoform test. It must be having the keto group and positive iodoform test. Iodoform test means active methyl group testing pressure. Sulfur methyl group. So look at here. This is phenolic group is there in option 1, so option wrong. And here positive iodoform test is not there now. In this option B, there is no positive iodoform test not there. And you can go for here also will be the positive iodoform test is not there. Come for here, ketone, it will be reactive with Grignard reagent ketone, and this is secondary alcohol, methyl attached, so this will give secondary alcohol in this methyl attached secondary alcohol is there, means that also will give the positive test with iodoform test, and this both will doesn't give the positive test with FeCl3 and as well as Fehling solution. So option D is the correct one. So 40, question number 40. The most suitable reagent for conversion primary alcohol to aldehyde, nothing but mild oxidizing agent. Which is the best mild oxidizing agent? Means PCC is the one of the best mild oxidizing agent. KMnO4 if you use means directly converted to carboxylic acid. K2Cr2 also will be directly converted to carboxylic acid. Even CrO3 also in presence of acidic media converted to carboxylic acid at high temperatures. So best one is PCC we can use. So next 41. And a compounds A and B following reactions are respectively. So formaldehyde treated with HCl will get as here, what will happen means will get here benzyl chloride will get benzyl chloride on treatment with this. So electrophilic substitution reaction. So on treatment with AgCN, it's a covalent character, right? It's a covalent character. So nitrogen can donate its lone pair of electrons, it is leaving. So due to that, we are getting as a here benzyl isocyanide, CH2NC will get benzyl isocyanide. So answer should be the C is the correct sense. Benzyl chloride and as well as benzyl isocyanide is the correct one. So question number 42. The major product is following is major product. Direct question, NCERT question. Cyanide and treatment dibol. This is dibol and followed by hydrolysis. Cyanide is converted to aldehyde. Dibol directly converted. So NCERT textbook line direct question only that. Next question number 43. 43 is increasing of pKa values. Since we know very well pKa is inversely proportional to the Ka. pKa is inversely proportional to the Ka. Okay, that means pKa is more, Ka is less. Ka is less means acidic nature also will be less. Acidic nature also will be less, decrease. That is the relationship. So they're asking here increasing orders, which is having the more. First, you should find the acidic nature order, which is more here. Your withdrawing group is there minus I and as well as minus N. Here only minus I is there meta position, and here should be the only plus M group is dominated. So withdrawing group is more acidic nature, right? So B is the more acid, and then later should be the C is the more acidic nature, then A is the more acidic nature, then D. This is the acidic nature order, nothing but Ka values. This is Ka increasing. They're asking about pKa. pKa is inversely proportional, right? So B is less than C, then A, and then D. This is the pKa value. pKa values. Check the where it is there option D, A, C, B. So option B is the correct student. Next question number 44. Amylopectin is composed by, amylopectin is nothing but starch. We have starch is containing amylose and as well as amylopectin. Since we know very well amylose is containing alpha D glucose 1,4 connection will be present. 1 and 4 connection will be present. In amylopectin 1,4 and as well as 1,6. Why? Because branching is present here. Branching. So That also will be the alpha D glucose, right? This is alpha. All those things are alpha. Where is their option? Alpha D glucose, C1 and C4, C1 and C6. They have given as a beta here, check. So beta is wrong. So alpha is correct. So option D is the correct, student. Next question number 45. Nylon 2, nylon 6 is a copolymer of nylon 2 is glycine and nylon 6 is aminocaproic acid. Aminocaproic acid. Option D is the right question. Glycine as well as aminocaproic acid. So these are the questions and answers, students. And if you have any doubts, feel free to ask. Please, if you have any doubts, please comment on the comment box. Thank you. Thank you, students.